review of putting some sequence. How come we've got a number of people missing?
That's a very good question.
People in Sanborn went home, and I don't know where Jason is.
There's Bartos.
I tried contacting him last night.
Okay. Questions on some sequence. Here's what I'd like to try and see if you can do this.
Oops.
You did some problems, and the big idea here is that you learn how to handle these Riemann sums.
Yeah, I don't get that.
And we'll talk about them a little bit more today. We're going to find other techniques, but the Riemann sums give us ways of doing mathematics.
Is it easy?
And so, first off is this.
Is it easy, Derek, the Riemann sum stuff? You're a bit off the screen.
Yeah, you should turn that a little bit, Mr. Kramer.
Will you help me?
Trevor, assist him. Straighten that out. No, Trevor, straighten that.
Okay.
That's the new one. Okay.
Hey, yesterday I had to spend way too much time trying to keep order here. So stay focused with me. We're going to do this one, and we're going to do it a couple of ways. And this is what we're going to do. We're going to go from 0 to 20. No, 0 to 10. So we're going to do this interval. 0 to 10. Thank you. Good. And I would like to break it into 20 parts. 20 parts. Okay? If I did that, how big is...
1.
No. How big is one interval?
0.5.
0.5.
Oh, it's a 10. I thought that said 20.
Okay? And so in this case, we have this. And this is important. This is like in our problems an A, and this is a B. So B minus A over N equals, and that's our delta X, which is 0.5. Okay, now, here we're going to go. We're going to do the easy one first. I would like to do this thing from the left. Okay? Now this is what I have. I have a nice little function here like this, a parabola, and I'm going to go way out here, out to 10, and I'm going to find these Riemann sums, these little sums all the way through here. Okay? Now where do I start? Because I'm going to start from the left. What's my first number here? What's my last number?
9.5.
And now what's my next number?
It's a 0.5.
And now that...
Little lace party.
Okay. This what I have here is my calculator first doing my sequence, and I have 20 numbers in a sequence, and it sums them for me. It does this stuff for me. Okay? And now I'm going to multiply by what?
0.5.
That happens to be my delta X, or the width of all these little Riemann sums. Yes?
Are those equations in the books with left, right, in the middle? Or we have to memorize those probably?
Okay, now, no.
No?
But we're going to talk about it. And now see, I like the question. What we're going to do, we're not going to have all of our intervals the same width either. At the beginning, we're doing them all that way, and then when we do the big gun one, sometime next week, we don't care how wide and narrow there are when we go to an infinite number. Okay. So, we'll talk about it just a little bit. And don't let me get out of here today without talking about what X bar is, because that deals with your question. Yes?
Okay, so when we do the left-right thing,
Yep.
does left mean you go to the point, then you go left of it?
We take the left side one here, and then this one, and this one, this one.
You go to the right.
Okay? Now, while we're at it, because the question is, review this thing. Now, what happens if I do it in the middle? Now I'm doing the middle next. And so everything is the same. Over here, x squared, x. What's the next one? Where do I start?
0.5.
What? 0.25.
Oh.
0.25. And I run to 9.75. And then I'm going to have all these 0.5s. And then again, times 0.5.
Right.
Brianna, you gave me a look on that one. You've got it.
I think so.
Okay,
I
good.
get how the calculator,
So-
okay,
Okay, yes, Grant.
go ahead.
Okay, so is the top one from the left side then?
This one is happening from the
Well,
middle.
wait, the blue is from, that one's from the middle, the blue is from the left.
Yes?
So then from the right, would it be
Okay,
1
now
to
just a
10?
second. Hold on, just a second. Brianna's going to tell you how we go from the right side. And we do all these things, and I was right up here. And this number is going to be what then?
1?
No.
Oh, yeah, okay, 0.5.
And then we're going to go to,
10?
yes, you got it. And then the rest stays the same.
So,
Who asked the question?
Grant did.
Okay. You're satisfied now with what we're doing here?
Yeah.
Now, I want this done because it takes all the tediousness out of this work. Because we can do it manually, but it takes so long, you make mistakes, and it's not fun. This is, I think, fun.
Oh.
Okay? Grant?
can you explain what those numbers are all in that sequence?
Oh,
there?
absolutely.
The
Now,
first one's the function, right?
yes.
Yeah.
Now, when you work with Excel, often you're working with 3, 4, 5 different inputs. Okay? And this is my function.
Okay, hold
This
on.
is-
Slide up.
Okay? And this is the variable I'm working with.
Good, very
Okay? And Excel does the same thing. And this is where I start.
Start.
And then I'm going to jump over one. This tells me how do I get to the next point. Every one I'm going to jump up a half.
Okay.
And then this is where the machine has to kick off. When it hits that, it stops. Okay?
So what's the 9.5?
That's the end point.
End point?
That, oh, yeah, 9.5 is the end point. That's when it kicks the program out.
0.5 is the interval?
The delta x, right? 0.5 is the delta x.
Oh, that is because we're going to multiply all of these by the width.
Yeah, which is the change, which is the last number there.
Yes, right.
Yes.
They just happen to be the same. Yes.
Wasn't the endpoint actually 10, but 9.5 is the last term minus that interval? So that it adds up to get to
Hey,
10.
Raph.
Okay, now on that, we're doing this one. You're talking about the blue one, Hope?
Yeah.
Okay, at that point, we're over here, and this is 9.5, and we're going like this.
Do you want to add 10? So that's why you stop at 9.5?
Yes.
Okay.
And I'm doing that, and also because on this side is the height I want to take. Okay?
Oh, I see.
Yeah. And so this is the last number I put in. I put in this one, and I have to stop here. So okay, got it? Okay, yes.
So the only time that you do the like the end of the range minus the change is when you're doing left. When you're doing left deal, you know.
I'm not okay.
I am too. Okay. So up there, you know, you did the 9.5.
Yes.
Okay, because you did 10 minus 0.5 minus the change or the step or whatever. Is the only time you do that is when you do it from the left.
Yes.
Okay.
Okay. Now I want to make certain you understand. Take a look at this one. This is the middle.
Oh
Yeah.
And in the middle, we have to start in the middle of the first one.
Yeah.
And that's 0.25. And the middle of the last one is 9.75. Yes?
Okay, so when you come from the right, when you do the right one, you add it to the first number?
Yep.
Okay.
Okay? Yes?
So your x squared there, is that for any quadratic function?
Yes, any quadratic function.
Okay.
Okay? And we have to do just a few so we get going, because you obviously see this is going to take way too much time to do things. Okay? And the thing is, here I did 20. I don't want 20. I want 1,000 in here.
Okay.
Okay? And so those get smaller and smaller, and that's what we're about doing. Okay? Now, yesterday we went really fast to get to this point. Any more questions on this? Okay, then what I'm going to do, we'll see how far we get. I want to review a couple things because we need these in just a little bit. And you've noticed this notation. That's indefinite interval notation, and I'm going to be shifting that today yet if I have enough time. Okay? Now, that was like to find our antiderivative, and when I had this, and you always find a dx back here, because this dx is going to form something like that delta x. They're going to have the same kind of role, okay? And this thing is going to have the summation role. Hopefully I'll get there today, okay? Yes?
Is this moving on to the next section then?
Some of it is.
Can you
No, oh,
can you do one of those summation ones quick? Just go over
Yeah.
it.
no, I will get there in a minute.
Okay.
I have another one on the list for today, maybe on Thursday or tomorrow morning. By the way, who's coming tomorrow morning? Anybody? Okay, good.
Yeah.
I only need one.
You gonna be here if there's no school?
I could be here, but we better not. I will be here an hour before school starts or whatever. We'll see what happens.
Okay.
Okay, here we go.
And okay,
Okay, just, yes.
so if we have like a late start, you're just gonna be like at 9 then?
I'll start an hour before class starts,
Okay.
if it makes sense. And by the way, we'll be here tomorrow, and I'll probably have an announcement saying we'll see what happens. I'll give you one warning this week anyway, no matter what. Okay, now, what is the antiderivative of this? Grant, will you give that to me? You know how to do these.
Oh, you mean the E, that thing? Oh, x squared over 2, yeah.
Okay, now, you notice how good he was.
Yeah. No, I don't.
Paula, what's this one?
Hey, are you
Yeah, are you Paul?
X to the fourth over 4. Question.
Okay, yes.
Wait, why is there a dx there then in the derivative again?
Here?
Yeah.
Come along and I will tell you more as we're going along. The only thing at this point that we had so far is when we did differential equations.
So we don't have to worry about that.
No.
Okay.
Yes, hope.
So that's just to say take the antiderivative.
Yes. Yes. And we'll doing this notation more. Okay? Tanner, what's the antiderivative of this?
negative cosine x.
You are good. Now watch this one. Jeffrey.
Yeah.
I'd like the cosine of 4x. Now watch carefully, here's where the fun begins.
Negative.
Negative.
It's positive.
Yeah, because
That is not the answer.
I know it's
It's sine
Good try,
times
Jeff.
over 4.
times by 4. Yeah.
Okay? Question on this? Okay. I'll do one. No, 2 more. Here we go. How about this one?
Oh, jeez.
ln of x.
X.
It actually happens to be this.
Absolute.
Okay? Okay. Now this one, I will not ask the question on a test. But it's one that says, hey, this looks interesting. And if it's like this, 1 over 1 plus x dx. That happens to be the tangent inverse of x. Okay?
Fine, yeah.
Because it has that, oh, this is supposed to be square too, I think. Okay? And so, now, just that part of review. And now I want to go to this. This is to motivate some of the things we're going to have in terms of the outcome. I have a velocity chart here, and I'm going at, we'll just make it simple, 2 miles per hour. Okay? How far am I in 4 hours?
8 miles.
8 miles.
You'll notice that it's this area, right?
That was nice.
Now, it could be Riemann sums if we wanted to.
Yeah.
All this like this. Okay, now, watch this. What happens to this if I would take the antiderivative of this? What is the antiderivative of this? Because I have here v at t
It'd be S
equals 2. And I would like s at t which is
2x plus c.
which is equal to 2x plus c. And now I think in this problem I can tell you what c is.
Oh,
Because s at 0 is 0.
So it's just 2x.
Okay, so it's 2x. Okay, now, the question is, that's what you said it is. What is s at 4?
8.
And you also said this area is 8.
Holy.
That is no coincidence. Now I'm going to take you to another one, and I have those picked up here really quickly. And take a look at this one. Now, and then this is all going to come together quite nicely soon. I'm speeding up here. Now I'd like to ask a question. How fast am I going at 4? At B at 4?
8.
Okay, I'm going at 8 miles per hour. Okay, now, how far have I gone? And would this also hold if this were 4? Would I have this area giving me that result?
Indeed.
Let's give it a try.
No, you'll have half.
Okay, now, this point is how high up?
It's
8 up.
8 up.
Okay, what's the area of that triangle?
16.
Okay, so this area is 16. Now let's do our other work. What is s at 0? Got that. Okay, what is v at t equals 8, oh, excuse me, equals 2t.
Yep.
No, let me do it over. V at t equals 2t. What is s at t equal to?
T squared plus c.
Okay,
Well,
but
t
c
is
is 0, so we have this. Okay, now, what is s at 4?
16.
Notice these two numbers are the same?
Yeah.
That's a coincidence.
No. Okay, I have one more. And that's this one.
Oh no.
Now look what happens. This is concaved up. So what is happening to my velocity?
It's going
Increasing.
And so I'm accelerating, right?
Yes.
Through this whole time. Now I'd like to ask you this question. How fast am I going at 4 seconds? Or 4 minutes? Or 4 hours?
16.
16?
Units.
Whatever.
I don't think so.
Why not?
How fast am I going? I'm going a lot faster than that.
Oh.
How fast am I going at B at 4?
186,000 miles per second.
4 squared happens to be 60, or that is
16.
Yeah, I got you.
That's what I said.
Okay, I was wrong. Okay, now look what happens here. This is 4, and at this point we could do the Riemann sum thing and getting more and more of these little sums to get the total. But let's just use the ideas we're using here with antiderivative. The antiderivative, we have v at t equals t squared. So s at t is equal to what?
T cubed over 3.
T
plus
cubed
c.
over 3. See that?
Nah.
Now, so what do you suppose s at 4 is equal to? See, that's where I'm-
64 over 3.
64 over 3. Now, is that kind of a realistic number? That's 21.
Yeah.
And you notice at this point we're already going 16 miles an hour. And so this is going to turn out to be exactly it. Okay? But I'm showing you this as we're going along just to get an idea.
Exactly what? How many miles you cover
This is how many miles we covered
in 4 hours?
In
4 hours.
Okay.
While accelerating.
while accelerating. Okay? Just to give you a little flavor of this kind of stuff. Okay, now the next one.
We're out of time.
No, we're not. Will you go along with me through a few things in the book? Some of you are going to have to possibly ask some questions next time, but the first page I want to be on is page 309. 309. You've read this stuff, and the definition. Okay, see the definition there? We are partitioning that interval up from A to B. And notice all those x sub zeros and ones and all that kind of stuff?
Yeah.
And you also notice delta x, the width is b minus a over n. That means they're all the same size at this point. Okay? Now look at the last, just before the end of the box there at the bottom, where you have this. It's going to be handy pretty soon. X sub k is equal to a plus k differences. See that? That's what he says there. I hope you don't have any trouble with that. That just tells you what this thing is. It's in that x, or their k along the way. So look at that so you notice this little bit of information. It's going to be helpful. Okay? Not terribly, but a little helpful. Next page, 310. Look at that definition of Riemann sums. And you notice he uses the thing x bar with a little k down here. And he says that is any point in the kth interval, subinterval. Okay? And it's in this subinterval. He uses x sub k minus 1 x sub k, that interval. Okay? We're breaking up all these little intervals, and this is the one in there. That's his terminology. I've seen books use this. I've seen them use other kinds of things. This is nice. This works well. Okay? And here he has a little discussion of right, middle, and left points. So check that out a little bit and notice the notation. Okay? Then, Derek a while ago had a question on page 313 dealing with the summation stuff. Okay? Now notice what we have at the bottom. I taught that first semester to you. The theorem 5.1. Now we will use, I think, the last one on that list, one of these first days, because I kind of like that one. I like the first one is obvious and easy. The second one is pretty good. The next one deals with this kind of stuff when you take sums, and it's not as easy as x cubes. But you just find it there. We're not going to do a lot with it, but it's there. You might take note. Okay? Now, the next thing I want to do, okay, now you have some reading there, 5.2. We'll take a look at some of those details next time. But here we go to give you an idea of what's happening. I wrote on here now, and I usually can't because it gets messed up. Here we go. I would like to have you look at this little function. This is right here. Okay? Yes?
Are you going to tell the x bar thing you said you're going to?
I just did.
What?
That is a value in the x bar sub k.
Okay.
Is a point
So it's an interval?
in this, so we have all these intervals like this. This is A and this is B, and somewhere in between here we have x, the interval k minus 1, and then over here is xk, and then x bar is someplace in here. Okay, and now this is the way it's going to look. Now we're going to see there's a function that's moving up here like this, and this point over here is going to be noted by f of x bar k. That's some point in that interval. Are you with me?
Oh, well, yeah.
Yeah. Okay. Yes.
How come they use xk minus 1 instead of xk to xk plus 1?
Okay. There's a reason for that. You wouldn't get in much trouble doing it the other way. See, he's saying why not this interval? Because this is the first one, which is x sub 0, and then this is going to be x sub 1. Okay, and see, so if you're going to go k, you put your first k in this one. And you start k with 1 instead of 0. Okay, let's go with this. Hang with me on this. How does this form up there?
It looks pretty good.
Okay, here we go. I would like to do, we're going to do a little bit of geometry, but I'm also going to show you how the calculus works. And in many ways, the calculus is easier than the geometry, okay? At this point, I would like to find the area of this thing right here. What's the area from 2 to 4, okay? And so this height is 11, and this height is 7, and so we're going to put it this way, 11, 7, take the average of that, don't we?
9.
Like this, 11 plus 7 divided by 2, and what's the width?
9 or 2.
2.
Okay, and that's going to be times 2 width, and so this is going to be equal to 18. Right?
Yes.
Mm-hmm.
So you divide instead of multiply when it's a triangle?
Oh, no. This is a trapezoid.
Oh, never mind.
Right trapezoid.
Yeah, but...
Okay, now, hang with me now. I'm going to show you something, and then I'm going to show you some notation. I'm going to do this, and I'm going to change it from an indefinite interval to an integral, definite interval, and I'm going to put a 2 here and a 4 here. Why? Because I have a 2 here and a 4 here.
All right.
Yeah.
Some of you are not watching. You're going to be really lost in a moment. Okay? And I'm going to put my function here, which is 2x plus 3. And then I'm going to put dx over here.
Which is 2.
Okay, now, this is very much like doing Riemann sums here, which would be like this. I will put an equal sign here, and I'm going to go over here, and I would do something before there in a minute. I'm going to go from k, or do I want to do an n? N equals, no, I'm going to go k equals 1 to n. And then I'm going to put here f of x bar k, like this. And I'm going to put a delta x here. Okay? Now, I have to tell you a few things. Now, what's this? This delta x is actually 4 minus 2 divided by n is equal to my delta x.
2 over n.
Okay? And this is some point in between one of these intervals, this height. That's one of those points in between. And another part here, f of x is equal to 2x plus 3. Yeah,
How would you enter that into your calculator?
you wouldn't.
I thought your changing
Okay.
x was just
Okay, now watch for a moment, and then I'm going to show you something in the book, and then I'm going to do something easy. You've seen all of this kind of stuff. What I'm going to do here is I'm going to take the limit as delta x approaches 0.
Oh.
Now you notice all of a sudden I'm introducing limit, and what I'd like you to do with me, just a second, will you go to page 324? Page 324. Now I'm assuring you that this gets a lot easier. Okay. Okay. Now, see the definition of integral? You see a definition of integral? You see this over here?
Yes.
And it's just like there, and I'm going to put this over here. Now, someone asked a question a while ago, which was a very good question. I blew it off because I didn't want to go there. How do you introduce this into your calculator? Well, this is going to be part of it, but I want to do that now. Yes?
Okay, so in the book it says it has delta xk. So do we need the k or is delta x?
Oh.
Does that matter or?
Yes and no. It matters if your deltas are all the same, and I have made all of mine the same.
Okay.
Later on, we're not even going to have them the same. But we aren't going to worry about it because it's just going to be a 5-minute or less conversation. Okay? So she says she noticed, which is very nice, the author put a little k there, but all of them are the same in what I'm doing. Okay, now let's do the easy part, which is in some part the calculus hard part, but you'll find it's easy. Grant is my antiderivative person, and so he's going to give me the antiderivative of this right here.
X squared plus 3x plus c.
Now, at this point, I'm going to not worry about the c's, and one of these days we'll see how they disappear. Okay, now watch what happens here. Now, by the way, this is our answer we're looking for. Now, what I'm going to do is I'm going to evaluate this thing from 2 to 4, like this whole quantity. I'm going to put this number in first. Watch that. And I'll tell you why later. That's going to be 16 plus 12, right?
12.
Any question? Now I'm going to subtract, putting this one in. And that's going to be 4 plus 6.
Oh boy.
Oh.
and that turns into 18.
That's weird.
It's weird. Okay, now next week, when I do more of this, I'm going to tell you, I'll give you a quote, that there are people who think that this kind of thing is one of the greatest discoveries in history.
What does it mean?
It's going to be the fundamental theorem of the calculus.
Oh.
Okay? Now, but today, what I wanted you to see, how this here, whole thing over here, turns into this. We only have to do this for a few days with our calculators. Only a couple of days. And we're not going to look at it again. But we're going to be doing this. Yes?
What's the value of your bar x sub k?
Bar,
That.
this here.
Yeah.
Okay, now that is, here. That means, Derek, that I have a little interval here, this little interval right here.
Okay. So it doesn't even play into your problem.
No, not, oh, except in the theory pretty soon.
Yeah.
Now that one, there's going to be a point up here. This point here is this thing right here, this here. Oh, see, where am I? Yeah, that's all right. That's what it is. That's that point right here. And then it's going to be times this width.
Okay.
Okay, so like the Riemann sums thing where we're doing. Or the calculator problem, yes.
Does it have to be that particular, or can it be anywhere?
No, it has to be in that interval. Has to be there.
Anywhere in the 7 to 11. So it could be 7.9, it could be...
No. We have said it's going to be right between this little interval right here, and that interval is going to go all the way up. Let me go down here like this, and this one is going to be all the way down here like this. It has to be in between here somewhere.
Yeah. So it can be
Got that?
where?
Are you with me?
So it can be anything in there.
Anywhere.
Oh, okay, now, we have been pretty simplistic. Where have we put that point? On the right side or the left side or the center? Okay, now look what happens. This is where we're going to go. We're going to squeeze this thing tighter and tighter and tighter and
Until it
tighter.
gets close to 0.
And then we're going to have all three of those at the same spot. Okay, I have a question over here. Derek, you have a question?
No, that's...
Okay, now, there's just more to this yet. I have two more, but I will get this one probably finished. Because it doesn't all work the way you might think it does. Okay? Now we have this one. And watch how this goes and see if it tweaks your thinking a little bit. Here's my function. Okay? Now, what is the area of this triangle right here? I think I can do it this way. What's the area of this triangle? Right here.
3 by 6 by 6. 9.
Okay, that's going to be 9. Okay, now, I have been measuring, Brianna, I've been measuring from here up. Now I'm going to be measuring down, so I'm not really going to have an area here. I'm going to have the sum of all these Riemann sums, all the way down here. All of these little sums. Add them all up together, and that's going to turn in, but if I were going to do an area here, what would the area of this be?
6.
2 by 4.
-4.
Yeah, okay.
Okay?
Why -4?
See, because the area of this thing in terms of area is 4. Okay? Because this is 2, and that's 4. Divided by 2 is 4. But now this is below, therefore we have a -4 here. Okay?
Negative area?
No, you can't have negative area.
So you can have a negative
Now,
number
okay.
in the problem.
Hey guys, hey, I really want to move because I'd like to finish this. You asked about negative area. That's why the book does a negative area thing, but I don't like that idea. I say it's Riemann sums, and we're going from this line here down. When we go from that line down, they're negatives, and so I call them Riemann sums. Okay? Now look what happens. What's the sum of these two? Very good. 5. Okay. Now, let's do this a minute. We're going to take this interval, and we're going to go, Grant, will you finish this thing up for me a minute? We're going to go from 1 to 6. This is dx, and he's telling me this is going to be
X squared minus 6x.
plus c, but we're not going to do that today. And because they disappear, and I'm going to do this, and I'm going to go from 1 to 6. You'll always subtract this one and you add this one, and we had to figure out why. Okay, so we'll put that in here. This gives me 36 minus 36 minus the quantity 1 minus 6, which equals,
-5.
no, not -5, +5.
Oh,
Good job, Matt.
Okay?
Wow, that was
Now, let's see. Will you go with me through the assignment a minute? Okay? We're on page 331. And, okay, 331, 19.
no.
Who would like to answer that question right now?
319.
Yeah.
331.
331.
331, question 19. It's very quick. He says, consider that limit, identify the the function there, and express the limit as an integral. So we're going to put it as an integral. Okay? And so in this integral, we're going to go from what to what?
0 2.
Okay? And we got a nice little dx back here. And what goes in front of here?
X squared plus 1.
Yeah, this calculus isn't bad, huh?
So 1.
So we got that one done.
1 through 5.
Pardon?
Well,
Well, you don't have to evaluate it.
what?
That's it.
That's it? That's nice.
He says identify and express the limit as an integral.
So 20 would be 4 minus x squared, and then with the little s thing, -2 2.
Okay, he says it's a little less thing. He's not going to get by with that for very long. Okay, hey guys, listen. Now, problems 23 and 24, net area and define integral. Okay, so it says sketch the graph of the integrand and show the region. Okay, so that is like I was doing with these problems here. Okay, finding the area geometrically. Not that derivative stuff. You find the area, and let's see, that's 23, 24, 27. 27, ditch it. Kinza, will you take 27 off there? Okay, now, 31 through 34 are pretty quick. See if you can read and figure those out. Don't spend a tremendous amount of time on them, because we'll spend some more time next time. Okay, now, today, I'm really happy where we're at.
I'm not.
So I don't think that take you that long. Make certain that you look at this and see if you have some questions along the way. Okay?
There are about 75 of you